Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth, we can now selectively, cleverly generate data that we can then use to train the AI. So for example, what comes into this AI, this Cosmos AI world model on the left over here, is the output of a traffic simulator. Now this traffic simulator is hardly enough for an AI to learn from. We can take this, put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from. Cosmos is the world's leading foundation model, world foundation model. It's been downloaded millions of times, used all over the world, getting the world ready for this new era of physical AI. We use it ourselves as well. We use it ourselves to create our self-driving car. Using it for scenario generation and using it for evaluation, we could have something that allows us to effectively travel billions, trillions of miles, but doing it inside a computer. And we've made enormous progress. Today, we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end to end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself, where we human drive it, using human demonstration. And we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all of population. However, it is very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And so let's take a look. Everything you're about to see is one shot. It's no hands.
Routing to your destination. Buckle up.
We started working on self-driving cars 8 years ago, and the reason for that is because we reasoned early on that deep learning and artificial intelligence was going to reinvent the entire computing stack. And if we were ever going to understand how to navigate ourselves and how to guide the industry towards this new future, we have to get good at building the entire stack. Well, As I mentioned earlier, AI is a 5-layer cake. The lowest layer is land, power, and shell. In the case of robotics, the lowest layer is the car. The next layer above it is chips. GPUs, networking chips, CPUs, all that kind of stuff. The next layer above that is the infrastructure. That infrastructure, in this particular case, as I mentioned with physical AI, is Omniverse and Cosmos. And then above that are the models. And in the case of the models above that I just shown you, the model here is called Alpamayo. And Alpamayo today is open sourced.